Welcome to the Explainer. Today, we're going to go on a little journey, starting with simple number patterns and ending up in the powerful world of algebra. It's a huge leap in how we think, and we're going to break it all down step by step. All right, let's jump right in with a little puzzle for you. Take a good look at this list of numbers. What is the one thing they all have in common? I'm guessing you saw it almost immediately. Each number is just 3 bigger than the one before it. And that simple act of noticing a pattern, that is the foundation of pretty much all of math, and it's our doorway into algebra. So we've spotted the pattern, but now let's learn how to talk about it like a mathematician. To do that, we've got to learn the lingo and define the different parts. You see, this ordered list of numbers isn't just a random bunch. It has a special name. It's called a sequence. Basically, it's any list of numbers that's following some kind of logical rule. And every single number inside that sequence, well, it has a name too. We call each one a term. Simple enough, right? It's just one piece of the bigger puzzle. So if we look back at our sequence, the number 3 is the first term, 6 is the second, and that means, you guessed it, the number 9 is the third term. See? It just makes sense. And when you have terms that are sitting right next to each other in line, like 6 and 9 or 9 and 12, we have a name for them too. We call them consecutive terms. Okay, so we know the names of all the parts, but the really powerful idea, the engine that drives this whole thing, is the rule that connects them. What's the exact instruction that's building this entire pattern? That instruction is called the term-to-term rule. Think of it like the secret code, or the DNA of the sequence. It's the one repeating step that creates the entire pattern. So for a sequence, the term-to-term rule is super straightforward. You just add 3. That's it. That's the whole secret code for this pattern. You take one term, add 3, and you get the next one. This also brings up a really key difference between types of sequences. A finite sequence, like the one on the left, eventually stops, but our original sequence is infinite. Those 3 little dots at the end literally mean it goes on forever and ever. Now, the term-to-term rule is fantastic for finding the very next number. But what if we wanted to find the 100th number? Or heck, the millionth number? We can't just sit there adding 3 over and over again. We need a much more powerful tool. And this is it. This is the exact reason algebra was invented, to solve this very problem. It's time for us to level up from just finding patterns to actually describing them with some real power and precision. And here is the big breakthrough idea. We use a letter, you'll often see N, to act as a kind of placeholder. Think of it like a box that can hold the position of any term we want. This special letter is called a variable. So let's see how we can take these new letters and combine them with the numbers we already know to build something totally new. We're going from just a variable to what's known as an algebraic expression. Let's break this thing down together. This is a classic algebraic expression. I know it might look a little intimidating at first, but I promise it's just a few simple parts all put together. First up, we've got the letter N. That's our variable. It's the placeholder for the number that we don't know yet or for a value that might change. Next, you see that number being multiplied by the variable, that 3? That's called the coefficient. Whenever you see a number and a letter squished together like 3n, it's just a shorthand way of saying they're being multiplied. So 3 times n. And finally, we have that number all by itself, the 5. That's the constant. And it's called that because its value is, well, constant. It's fixed. It doesn't change. It's always just 5. So now that we know these basic building blocks, the variable, the coefficient, and the constant, we can do something incredibly powerful. We can start translating plain English phrases directly into the super concise language of algebra. For example, let's take a simple phrase, 3 more than n. How would we write that using the building blocks we just learned? It just becomes n plus 3, and that's it. We just translated a normal phrase into a clean, powerful mathematical expression. This skill is the absolute core of what algebra is all about, and it lets us solve some unbelievably complex problems. So there you have it. We went from just spotting a simple pattern in a list of numbers to building a tool that can describe any part of it. You've just learned the fundamental grammar of a brand new language. And the only question left is, what other patterns out there in the world are you going to describe with it?